Thank you, Larry. All right, everyone. Can we believe another month has come and gone? We're doing this again. So, in the continued expansion of diving into the human body, we're going to attempt to make the human balloons inside of our chest called lungs fun and exciting and tie it into what we do as a digestive wellness company. So, I like to do this every time just so we understand the whole process, the beginning, the middle, and where we are now. We started off with energy, then we went to the heart and the vasculature, then we dove into the lymphatic system. I really hope people took the heart, just how important that is. And today we're going to be giving the lungs some love. So as per usual, some really random facts about the lungs that I did not know that are pretty cool. They're the only organ in the human body that will float. So if you want to be found, just cut a lung off and let it float up to the surface if you go on down in a plane crash. The lungs, like many other areas of the body that we used to think were sterile, are in fact not. We'll get into that. And they work very closely with your nose and nasal cavity to be a filter, a heater, and a humidifier. So remember the rule: if you pick it, you better flick it. Nothing else better happen, because what's in a booger is more than you probably want to know. When you breathe out, you actually dehydrate yourself. Now, it's not even an ounce of water per hour, but every time we respirate, I don't know if anyone remembers from the very first lecture, I asked, why is oxygen an important molecule? And it's to make water when we make energy. So we actually hydrate ourselves when we turn food into energy, and we dehydrate ourselves when we breathe out. So the yin and the yang of the human body has yet another examination. And when we sneeze, that bad boy leaves our face at about 39 miles an hour. So if you've ever been next to someone and they've hit you point blank, you feel the force of it, you know why. And even though the lungs do inhale about 11,000 liters, and in gallons, I don't know what that is for the American, everyone else, all you Americans on the call, that's a lot of air, but only 20% of the air we breathe is oxygen. And that's probably going down. So if you ever hear me call someone an oxygen thief, you understand why that word is so important. And the world record for holding your breath is 24 minutes and 37 seconds with one breath. I believe the gentleman who did this is some kind of free diver. So he's partially, I don't know, an amphibian or a whale or something that can hold his breath a ridiculous amount of time. So I thought that was really interesting, because fundamentally, this is what we're looking at. We're looking at the air inlets. So the intakes and the tubes that feed off to the branches that eventually get into the lungs. So what we're trying to do in this diagram is we're understanding it goes from big to small. On the left, we're looking at the route of the air going into the body. And when we go over to the right, we see those little like bundles of grapes and little sacs. It comes back to the alveoli and the capillaries, like we talked about in the cardiovascular system. It's about the path of oxygen delivery and carbon dioxide release. And for people who do want to dive in a little bit deeper, the second webinar will definitely be more technical, but just to get a familiarity, we talk about the trachea. That's the windpipe. The bronchi is the actual airway that goes into where it branches off to the left and right lungs. It feeds the bronchioles. So the lungs themselves are spongy balloon-like tissue that expand when they inhale and contract when they force air out. The bronchioles are the air passages that get to the alveoli, which are those tiny little air sacs that fill up with air. And the whole purpose of this is to get oxygen from the environment that we breathe into the bloodstream. So if you remember from our second webinar, anything you see that's red, that's oxygenated blood. Blue is deoxygenated blood. Each breath you take goes this route. It goes down the windpipe to the bronchioles, to the lungs, to the alveoli, and eventually to the capillaries when we breathe in. And when we breathe out, the reverse action happens, and that's the intake of oxygen and the exhalation of carbon dioxide. So to know that through the path of travel, it's a really fundamental process when we're talking to people about respiration, that we understand what the entire purpose of it is, but also the differences between the inhalation and the exhalation. So rather than go over this in grave detail, I think we get this process, and this process repeats until it doesn't, meaning that, you know, we can survive. I've said this before, we can survive without food for a few weeks. We can survive without water for maybe a day or two. As long as you can hold your breath and utilize oxygen, as long as your body can sustain life without it. So we really start to see just how essentially important respiration is as a process. And to give a little bit of foreshadowing to the next one, breathing is under autonomic control, unless you're doing some kind of deep breath work. And Jeff and I have mentioned about doing things like Wim Hof breathing. Has anyone tried more intensive breath work before? It can be like a transcendence in terms of a feeling sensation outside your body, because you're hyperoxygenating, you're upregulating energy production, you're upregulating some aspects of detoxification. But for the most part, breathing is entirely under autonomic control. Your autonomic nervous system, which contracts your diaphragmatic and respiratory muscles to keep that process happening without our thought. And the quick and dirty is inhalation from the environment, oxygen in, transfer to the bloodstream, carbon dioxide out, exhalation back to the environment. And there's a reason why it's oxygen in, carbon dioxide out. That's kind of a bigger picture environment. We're so connected to the earth. And I've mentioned this many times over that, patterns we see in the human body are patterns we see in nature, and relationships that we rely upon for the sustainment of human health are interlinked with, the environment that we interact with. So the carbon that's in plants, when the sunlight hits it, actually excites water molecules and creates not only food, carbon foods, fats, and carbohydrates that we eat, but it also creates oxygen that we breathe. So the very environmental interaction of sun with plants creates that which sustains us. After we utilize it, we bring that oxygen, we bring that nutrition into our body, we make energy, and we breathe out the very substrate that the plants utilize to interact with the sun to make their food and sustain their life. So it's an entirely interlinked system. And I thought this was so cool. On the left, you see the branches of bronchi and alveoli in the lungs, and right is just the tree branch. That's pretty interesting, isn't it, in terms of its understanding? So with this, I think that it's an important concept to mention that if you think about this picture right here, what happens when the trees start to die? What happens when our environment gets compromised? The earth's lungs no longer breathe properly. What happens when we live in that environment where the earth doesn't breathe properly? We're breathing contaminated air, and we're bringing negative consequences potentially into our bodies. It gets into our bloodstream, it gets into our cells, and our bodies have to deal with it somehow. So it's really coming back to this, understanding why we breathe and why it's a foundational thing to think about, consider, speak about when it comes to health. If you remember the cardiocirculatory circuit, so the deoxygenated blood goes to the lungs, oxygen goes into lungs, oxygenated blood goes to the heart, it's sent out to the tissues, the gas exchange happens in the capillary bed, so the oxygen goes into the cell, the carbon dioxide leaves the cell, and then that deoxygenated blood goes back to the lungs. I really wish I had found these graphics when it came to explaining the cardiovascular system, because it shows you just how these two systems are absolutely essential. And if we're talking about health, it doesn't matter, I heard Susan mention metastatic cancer. If we're talking about PANS or PANDAS, autism, we're talking about autoimmunity, any specific condition where the body is not functioning optimally, this circuit is compromised. We're not getting oxygen in the tissues. We're not getting waste materials out of tissues. And it really does come back to the concept of energy in, which is very much dependent or requiring an adequate oxygen status. And then water and carbon dioxide out, because if there is no energy, there is no life. So whomever your clients are that do deal with any kind of respiratory conditions, anything that does focus on the lungs, the cardiovascular system, whatever, it starts to give you some more ins or potentially some more talking points to open up the dialogue to see how they consider these concepts as a frame of reference for how they approach dealing with clients. And maybe that's how you can open up some potential avenues for conversation about bringing in some solutions that they may have never thought about. Because most people don't think of the microbiome in the lung. They don't think of the microbiome in the oral cavity. They think of the microbiome in the gut. Why? It's the most well-researched one. It's the largest one for whatever that's worth. And it's the one that we experience the most obvious signs of change in, because the GI system is an incredibly dynamic system. However, if you look inside the respiratory system, you have a mucosa, you have goblet cells. So we also have these cilia, these tiny hairs that move mucus in a wave-like motion, because what you breathe in, What gets past the respiratory checkpoints in the nasal cavity, the adenoids, the tonsils in the oral cavity, and the mucus gets into our lungs. So if we didn't have something to trap those particles, then we would actually be bringing those things directly into our system on a regular basis. It would be like if you didn't have a humidifier filter in your house. You just had an open element to the, or an open chamber to the air outside. Whatever blew in from outside, you'd be breathing in. And we also have lungs that are able to reside within the mucosal barrier within the lung. And that's interesting because where have we seen this pattern before? We have a mucosal membrane and we have a bacterial colony. This is true of anywhere there's an interface between the inside and the outside of the body. So why does this exist? Well, if we have a mucosa, we have immune cells. If we have immune cells, we need those immune cells to be educated and we need something to talk to them. That's why the microbiome in the lung becomes very uniquely developed person to person. And it also becomes developed based upon what's coming in, because it comes back to a very important concept of the human body. If something gets past our physical barriers, it's into the bloodstream and it's into the lymphatic system, which means it's likely into the tissues and into the cells. So if that happens, what's the problem that our bodies are facing? I'd like someone to answer to see if you guys are catching my drift so far. Anyone except Jason? No offense, Jason. Don't all speak up at once.
Toxicity.
Boom. We have things in our body that is going to compromise our health. Anything that's a chemical, airborne, environmental toxin, a pathogen, a virus, if it gets into our cells, it causes an immune response, which means inflammation. If that inflammation is local in the gut, well, could it be that it could then become systemic? Absolutely. That's the path of how all these things try to leverage using us as a host for their benefit. Because remember, they want to survive too. And when it comes to understanding the sinus and the oral microbiome, it's still, I would say, a fairly new area of comprehensive research where things are fully elucidated, understood, and agreed upon. But fundamentally, the same laws hold true. So anyone you talk to about the concept of how you're born, is it cesarean or is it natural birth? Are you formula fed or are you breastfed? Were you given, courses of antibiotics at a young age? Did you have siblings? Was there smoking in the house? I could add, did you grow up with a pet? Did you live in a city? These things will affect the respiratory and the microbiome of the lungs. It's not just the gut microbiome. So we're starting to see the pattern of what we talk about from a gut perspective to some degree can be repurposed to talk about anyone who has chronic respiratory problems, things like asthma, sinusitis, rhinitis, all of these scenarios, seasonal allergies. There are very strong connections to the gut microbiome, and it's an obvious connection to the respiratory microbiome, because if someone has debilitating seasonal allergies, the bugs in their mucosal linings a little higher up, and the immune cells are extra vigilant and hyper responsive. So we know that they have a higher state of default resting inflammation and immune activation than other people probably do. Because you can see the same thing is held true with the oral microbiome. The kind of foods you eat, the quantity of sugars we eat at a young age. If we smoke, do we floss? Flossing is actually more important than brushing from an oral perspective, because flossing actually interacts with the plaques and breaks up the very things that bacterial infections could potentially hide in. Oral diseases, things like canker sores. Have we been using medications that will then develop an oral problem that could lead to a respiratory problem? Because think about it. If we have an oral issue, if we swallow, it hits the gut microbiome. If we have an oral issue and we inhale, it hits the respiratory microbiome. So then all of a sudden something local in isolation becomes more widespread. And if that somehow manages to breach the barrier, like I don't know if leaky lung is a thing, but I would probably assume that it could be. If it breaches the barriers of those mucosal linings, the same story holds true. It gets into the bloodstream. And I don't know if you noticed that initial or the second graphic of the respiratory system, there were lymph nodes all on the trachea. So it can get into the lymphatic system very, very easily from the respiratory system because they're very much interconnected. And respiratory microbiome dysbiosis is actually a thing. So, it might break the balance of the immune system to drive lung inflammation because it's typically in the lower respiratory tract. So right here, it says the pulmonary microbiome on health and critical illness. In healthy individuals, lung and gut harbor markedly different microbiomes. The composition of the lung microbiome closely resembles the one of the oral area. So if we have oral issues, the likelihood for lung issues goes up. Think of how many kids are running around with, numerous cavities and various other things of that nature. But potential pathogens can enter the lung via aspiration and possibly translocate from the gut as well. The resulting state of dysbiosis promotes inflammation and acute injury of the lung. So what that says is you can have it coming from two different ways. It can come in directly from the lung or from the oral cavity, or it can translocate from the gut, which I found graphics. So on the left-hand side, you see that there's a normal gut microbiome that has a different configuration. In this context, we see these little green rectangles, and a normal lung and oral microbiome that's composed of blue circles. On the left, it's a happy state. Why? Because this is how it's meant to be. A gut microbiome should not resemble a lung microbiome, and I'll kind of get into some of the characteristic differences later on. However, if you have leaky gut, if you have excessive translocation, and they're using the terms acute respiratory distress syndrome or sepsis, which I have known a few people to have very strange exercised onset asthma, where they're in the middle of like a distance run, and all of a sudden they start pushing and running harder, and they start gasping for air and they pass out. And the autonomic nervous system is kind of looped into that because those mechanisms are regulated by the nervous system. But if someone has gut dysbiosis and gut translocation, it's very possible that that systemic problem will find its way back up to the oral cavity and the respiratory lining. Because there are some characteristics that do matter. So a decreased diversity and an overgrowth of bacteria in the lungs seem to be the main problem. The lungs should not have a high quantity of bacteria, but they should have a high diversity of whatever is there. And it seems to be an acute to systemic response. If you have an acute response within the lung, it can become a systemic response if that problem becomes chronic enough. So for understanding this, that's a very different philosophy from what we're taught with the gut. Within the gut, we're supposed to have high diversity, high abundance, not overgrowth. Within the lung, it's high diversity, low abundance. So we want to make sure that these axes, the gut-lung axes, are very much maintained in a healthy state. And besides using strategic supplementation, just kind of thinking out loud here with logic, we know that that's food selection, the supporting of digestion, the insurance of making sure we have adequate fibers and food diversity for the creation of short-chain fatty acids. So what goes into the gut and the stomach maintains a healthy gut microbiome and makes the leakiness less likely to happen. And the environment that you're living in, making sure that you're not breathing in chronic airborne particles. If someone has chronic excess production of mucus or phlegm, a chronic cough that's long and latent, you already know there's something problematic within the lungs. And I like how this graphic shows that an issue in one area automatically affects the issue in another, but it seems that an intestinal inflammatory problem will more likely cause a lung problem after the fact. So the long and short of it is, if your clients are dealing with gut problems, considering the lung and considering how to formulate an approach that becomes a more systemic dysbiotic approach is really good. And here's another rehashing of what I said, but the important thing to remember is, in this context, the gut is really the anchor. So a loss of gut diversity and dysbiosis seems to influence the immune response within the lungs. What does that mean? Enhanced white blood cell activity within the lungs, causing a more powerful or potent inflammatory response. The inflammatory response within the lung mucosa itself, so the oxygen exchange will potentially be reduced, as will the ability to breathe and become slightly hypoxic. And then the translocation from the leaky gut could reciprocate in overgrowth in the lungs. And then, not stating the obvious, breathing shitty air won't help either. Making sure that you're filtering your air in some way, shape, or form. So when it comes to connecting microbiomes, we know that more than the gut is starting to emerge. The oral, the nasal, the respiratory, the gut, they're all starting to have their own unique properties that is being accepted. But within the gut, we know that the stomach, the small and the large intestine all have a little bit of a unique signature to them themselves. So I wanted to create, my laws that I would say that govern the microbiome. So imbalance in one can be acute, meaning you can have a problem within your oral cavity or your nasal cavity or your gut cavity that may not interplay with any of the others, but a chronic singular imbalance in that specific cavity will likely or may lead to a systemic imbalance. Dysbiosis is always connected to the inflammatory response of the immune system, and the body is always trying to trap and remove threats from pathogens. So if you go back to the very first thing, we talked about energy being primordial. If the body's under attack, talking about the cell danger response, energy to sustain life is being directed away to the immune system and other systems as energy to try to fight off a threat. So we have a cardiocirculatory system with circulating immune cells. We have a lymphatic system with lymph nodes and lymph tissue, and we have mucosal linings, all designed to try to keep things that are going to compromise the body out of the body. So if you have clinicians who are focused on the respiratory system, if you don't talk to them about the essential nature of working on the GI system, it's easy low-hanging fruit for them to potentially help some stubborn patients. Every single person I've ever met who has chronic asthma has a gut problem. And it's a really important thing to mention because a lot of children develop asthma after multiple courses of antibiotics for a likely gut infection or some kind of infection in the first place. So you're seeing how everything comes together. And man, Raf, how'd you do this again? Oh, I didn't know you got in here, man. So, even Raf is trying to tell people the importance, the essential nature of making sure that you keep your immune system strong with probiotics and with enzymes. And look how brave he is. That sneeze is coming towards him at 39 miles an hour. He's not even flinching. He's like a Zen master. So Raf, thanks for your contribution, man. I always know that you're going to show up at one point or another in these presentations. So thank you for the work that you do. So looking at supporting the respiratory, the oral systems, and all that kind of stuff, these are some best practices that I've implemented with a lot of clients, and then understanding there are some rules to the game. So things like oil pulling, flossing, tongue scraping, using a neti pot. I don't know if anyone's ever tried that. That's a horrible experience the first time you do that, to have water shoot up one side of your nasal cavity and out of the other. Just make sure the water is not too hot. Not saying from experience, just theoretically. Another cool thing is a nebulizer, where you can actually nebulize colloidal silver, for example, or use saline or silver nasal spray. Because if someone's dealing with chronic respiratory things, the same order of operations is true if it's also something that's in the bigger picture, a systemic problem. Deal with the local areas and then think about the overlap. Because again, when it hits one microbiome, if you have chronic sinus postnasal drip and you're swallowing that all the time, that's going into your gut. Hopefully you can deal with it. Maybe you can't. If you're breathing contaminated air all the time, that's going into your lungs. Maybe you can deal with that. Maybe you can't. An important concept is the air in your home is likely much dirtier than the air outside of a downtown core. So that's why I like using things like HEPA filters and humidifiers, because the air you breathe, especially if you have carpets, if you have pets, if you have children, anything can add particulate matter to the air. And if you could see what the air around you looked like, if we could actually see on the microscopic level, we'd probably stop breathing. It would probably make us wear masks rather than just, media fear. But that's a story for another day. So in my mind, these are what I call the low-hanging fruit to reduce the burden on the lung mucosal immune system. And fundamentally, if you do have those that practice energy medicine, traditional Chinese medicine, energy testing, I thought this was kind of interesting because in Chinese medicine, the lung and the colon are very interconnected. It's one of the reasons that I chose the probiotic I did for this feature. So the lung is essential for the delivery of qi to the body, but the lung is also the grief center. So the lung receives and the intestines release. So if the colon isn't moving, oftentimes in Chinese medicine, they'll say, oh, that's a respiratory problem. But think about that for a sec. How can we take that connection and say it differently? Well, if the respiratory system can't deliver oxygen properly, maybe there's an inadequacy because there's an inflammation in the lung, which could potentially be as a result of an inflammation in the large intestine, or vice versa. So I really have this fascination for trying to understand what different philosophical approaches are saying and try to unify how they're saying it. Because if they're talking about the energy in the lung and the large intestine, well, we just elucidated that there are very interconnected colonies of microbes that are essentially their own ecosystems in both places. And if one is compromised, the other will likely be compromised. So all of your clients, physicians, practitioners who are dealing with respiratory issues, if they're not thinking about the GI system and its connection, it could be a massive bonus in terms of having them increase their client likelihood of success outcomes when they start to make their decisions.